Welcome to This Explainer. Today, we're diving into something I absolutely love. We're going to look at ecosystems, but through a totally different lens. Imagine an ecosystem as a bustling, incredibly complex city. Just like any major metropolis you can think of, an ecosystem is absolutely packed with a wildly diverse range of citizens. It's got these highly specific living arrangements, some involve very close roommates, and of course, everybody has to secure a highly specialized job just to survive.
So here's our roadmap for today. First, we've got the power of biodiversity. Then, symbiosis, living closely together. And finally, niches and fierce competition.
All right, let's jump right into Section 1, the power of biodiversity.
Now, we really need to nail down this distinction right off the bat because it's incredibly important. When scientists talk about biodiversity, they're usually measuring two completely different things. On one side, you have species diversity. This is quite literally just counting how many different types of things live in a specific area. But on the flip side, you have genetic diversity. These are the hidden internal differences within a single species. Think of it like this. It's the difference between counting how many different professions exist in a city versus looking at the unique individual talents of the people working within just one of those professions.
And guys, the sheer significance of this biodiversity, it really cannot be overstated. The stakes are absolute here. A highly diverse ecosystem literally provides our essential medicines. It balances out the carbon dioxide and oxygen levels we breathe, and it guarantees food chain stability by offering a huge variation in food sources. Plus, all these different organisms provide physical shelter, they enrich the soil, and they act as this brilliant natural check and balance system to keep predator and prey populations perfectly stable. Which brings us to a really fantastic note from the original source material. It says, we literally don't want to cut down rainforest in case there's an undiscovered species that cures illness. I love that. It's a very real, very human application. When we lose species diversity, we're not just losing a cool animal or a pretty plant, we're potentially losing biological secrets and medicines that haven't even been discovered yet.
So that's species diversity. But looking inward at genetic variation, man, this is essentially nature's ultimate backup plan. By having all these different adaptations and variations hidden within a single species, that population becomes incredibly resilient. Let's say a devastating disease sweeps through, or there's a sudden massive shift in the environment. Well, genetic diversity ensures that at least someone in the population might have a specific hidden mutation that helps them survive. Without that genetic variety, a single threat could wipe out the entire city. No backup plan whatsoever.
Okay, moving right along to Section 2, symbiosis, living closely together. Now, by definition, symbiosis is a relationship where two species live closely together. But, and this is a crucial but, here is the golden rule you have to remember. In these incredibly close roommate situations, at least one species always has to be benefiting. We're not talking about two strangers passing on the street here. They are entangled in a way where at least one party is getting a definite biological payoff.
To make this super clear, we can actually categorize these interactions using a really simple mathematical framework of plus, minus, and zero. In commensalism, species A receives a benefit, so that's a plus, while species B is completely unaffected, a zero. In mutualism, it's a plus for both, literally everybody wins. And finally, in parasitism, species A gets a plus, but it comes at the direct expense of species B, which gets a minus because it's actively being harmed. Let's look at exactly how these three scenarios play out there in nature.
First up, commensalism, the plus-zero relationship. A classic example here is birds and cattle. As cattle graze and stomp through the tall grass, they stir up tons and tons of insects. So the birds just follow closely behind them, getting a massive benefit. Essentially a free, easy meal. That's a plus. The cattle? They honestly don't care at all. They aren't helped, they aren't harmed, they're just completely unaffected. A total zero.
Next, we have mutualism, the plus-plus relationship. Think of the classic clownfish and the anemone. The anemone provides the clownfish with this really safe, stinging shelter to hide from predators, while the clownfish cleans the anemone and actually chases away polyp-eating fish. Both species actively win here. It's basically the ultimate cooperative roommate situation in our biological city.
And finally, we've got the slightly darker side of city living, parasitism, the plus-minus relationship. Take a specific kind of wasp and a caterpillar. Certain parasitic wasps will actually lay their eggs inside a living caterpillar. Yeah, it's pretty brutal. As the wasp larvae hatch, they feed on the caterpillar to survive. So the wasp drastically benefits, a massive plus, while the caterpillar is definitively harmed and eventually destroyed, a huge minus.
All right, let's head into our final part, Section 3, niches and fierce competition.
So, ecologists define a niche as an organism's specific role in an ecosystem. But to make this perfectly clear, I absolutely love the handwritten translation right next to the definition in the source material. It's a job. A niche isn't just an organism's address, it's what the organism does. It's how it eats, when it hunts, how it survives. It is its precise profession within the ecosystem.
Which naturally leads us to a highly volatile scenario. Think about it. In an ecosystem with limited space, limited food, limited resources, what happens if two entirely different species apply for the exact same job?
Well, to see this in action, let's look at these top two graphs showing a couple of laboratory populations of paramecium, specifically P. aurelia and P. caudatum. When they are grown perfectly separately in their own environments, just look at those population curves. They both exhibit really beautiful, healthy, S-shaped logistic growth. They thrive because they have their own space and their own resources. No problem, right?
But watch what happens when we force them into the exact same space. Down in the bottom graph, both species are placed together, fighting for the exact same niche. And the result is immediate and it's dramatic. Over just a matter of days, P. aurelia completely outcompetes the other. While Aurelia's population climbs and thrives, Caudatem's population curve absolutely plummets straight towards zero.
This data perfectly illustrates a golden rule of ecology. No two species can occupy the same niche or else they will compete. And as the notes in the margin clearly point out, the loser of that competition will not live in the same area anymore. It's cutthroat. One gets the job, and the other literally gets evicted from the city entirely.
So, we have this incredibly complex, biologically diverse city, right? Every single organism is fighting tooth and nail to maintain its specific job and its specific roommate relationships. But knowing just how deeply interconnected and delicate these niches are, I'm going to leave you with this to consider. What happens to the health of the entire ecosystem when a disruption occurs and just one of those vital jobs goes unfilled? Thanks for joining me on this explainer, and keep questioning the incredible mechanics of the world around you.